All right. So I think today we'll just talk about review stuff, if that's okay.
Do we have class on Friday?
Nope.
Okay.
Do you want class on Friday?
Yeah.
Yeah? Sure.
I'll come in.
Yeah. Is anybody planning to take the test tomorrow, or are you planning on Friday?
I was possibly, because Dr. Olson canceled advanced calc, she's going to the conference.
Right.
And I have no classes, so it'll be nice.
Okay. Well, what time do you want to do it then?
Does the 9 work in the morning?
Maybe. Because I won't be here at 9, but let me see if I can get the test together, if I can.
Otherwise, my next break isn't until after numerical.
After numerical's fine, too.
Okay.
Yeah. Because I'll actually be here for that.
Yeah. All right. Well, then I'll just do it then.
Okay. Anybody else plan on doing it tomorrow? And since the other people here are here, I don't care when they're going to do it.
I told Nawaj we have a test. But
Yeah. I wouldn't tell him. Let him come to class and figure it out. And that's for being recorded too, by the way. Has anybody seen Marshall today? Speaking of that, I need to email him. Okay, I need to email him then, because I need to tell him that I wasn't able to record class yesterday. So turns out it really didn't matter, but I wasn't able to record class yesterday because he actually asked about it. All right, so things that we need to remember.
Is that Wednesday?
I think it's Wednesday. Feels like Wednesday. Actually, it feels like Monday has been just going over and over and over and over again all week. It has not been a good week. Yeah, so too many meetings yesterday. And meetings with administrators are never good. So, I mean, I wasn't in trouble or anything. It was just meetings with administrators is never good. So, anyway, what was I talking about? Oh, stuff for the test. Good. So we talked about the beginnings of hypothesis testing stuff. In particular, some of the things that you might be asked to do are calculating a type 1 error. There's Kelly. How are you doing, Kelly? Good. When are you planning on taking the test? Are you planning on doing it Friday?
Yes.
Okay. What is type 1 error again?
You reject
The alpha, yeah.
H null when it's true.
Okay. So that's exactly right. The probability that you reject H naught given H naught is true.
Hope I can remember that.
Yeah, because you always flip them. So remember, for those types of problems, and what I'm going to write down here in a minute, usually you're given a scenario. Typically, it's whatever parameter equals a specific value for your H naught. For your HA, your parameter is equal to another value. And then you have some condition on when you'll reject, and you'll calculate this probability based on which one is true. So we've seen those where you might have an exponential distribution. The parameter is one thing under H naught, and it's another thing under H1, and it says you reject if you have some certain thing calculated in the sample that's above whatever. So it might be exponential. You could do something with binomial or Poisson or any of those kinds of things, right? Because all of those have parameters. Okay? So we can calculate those kind of things. You can also do calculating a type 2 error. And what is a type 2 error again?
You don't reject H null when HA is true.
Right. In general, this is the harder of the two to calculate. Because a lot of your null hypothesis is typically a simple hypothesis. parameter equals specific value. However, in practice, your alternative hypothesis is typically a compound hypothesis. HA is the parameter is greater than a value, or the parameter is less than a value, or the two parameters are not equal to each other, right? That's usually a compound statement. So that beta is typically hard to compute. So if you're being asked to actually compute it, you will be given enough information to calculate this probability exactly. Usually the problems were involving having a simple statement for your alternative hypothesis to be able to calculate the probability, so you can pick one or the other for your parameters, those kinds of things. From this beta, you should also be able to do power. And what is that defined as? Yeah, 1 minus your beta, good. Honestly, as far as so far this semester, it's these things that I'm going to be concentrating on as far as calculating a type 1 error, calculating type 2 error, and doing power. Later on this semester, we'll talk about trying to get an idea of getting a handle on the power of a hypothesis test, trying to make your hypothesis test as powerful as possible under a certain set of criteria. But for right now, the types of problems that you've done where you've calculated beta or calculated power are the ones that you should look back on, make sure you understand how to do. And if they're calculating probabilities of things, it's really going back to kind of last semester ideas and grabbing those types of distributions. I'm not going to make you remember any of the funky distributions. If you know exponential, if you know binomial, if you know Poisson, it'll be something along those lines.
So the closer it is to 1, is that?
The better it is, yeah. The closer the power is to 1, the better it is. Yeah, I mean, that's the idea. You want your alpha to be small and your beta to be small, but you want them to be both small at the same time. You want to make both of those probabilities to be little, if you can. That's a hard thing to do, in general. Usually, the only way to really do that is make your sample sizes bigger. All right. So then we actually did some hypothesis testing, and that's pretty much been the focus since we had the last test, right? Okay. So in section 7.1, we did tests on proportions. So you had, when you're doing these tests on proportions, you've got a couple of different test statistics. So look back on, on pages 346 and 347. So on page 346, your hypothesis test was your P is equal to a specific value. That was your null hypothesis. Versus on page 347, it's when its two proportions are the same. In particular, in this scenario, for the proportions being the same or not, you had to do that calculation of the p hat to get your common variance idea, kind of a pooled variance idea for proportions, where that p hat was the y1 plus y2 over n1 plus n2. Again, these are listed for you. There's nice shaded boxes on those 2 pages, as opposed to me rewriting them all. Just give you where you can go look, since you already should have them in your notes anyway. But I did want to point out that when you do the hypothesis testing for one proportion being equal to each other, another, or one's bigger than the other, okay, you have to do this pooled idea to be able to get that estimate for your variance. And you'll see that in the denominator for your test statistic. Remember, all your test statistics you're using either the normal distribution, the t-distribution, or in the cases of things that you're doing, well, you could be using F as well, but all the F test stuff that we'll be doing will be on Excel, so you don't have to worry about the F tables. But normal distribution, t-distribution, and chi-squared distribution using the tables. Okay. All right. So anyway, but all those test statistics especially for normal and t, look the same, right? You do parameter minus value and divide by standard deviation, because you're basically both the t and the normal look like the same idea. The chi-squared one's a little bit different, but all right. So then 7.2 was tests on a single mean. Here, your test statistics are on page 356. One of the things that you should be able to do out of this particular section for a large sample is to be able to give me a p-value from the normal distribution table. Remember, the p-value is the probability that being greater than the sample you got is a certain value, or less than the sample you got is a certain value. For t-distributions, without using Excel, you can only get a bounds, right? That'd be in between two t-values. We've done problems like those.
Be able to get the p-value from the t-distribution?
For the normal distribution.
From?
Yeah. From a t-distribution, you can only get bounds from the table. Because remember, the t-distribution only gives you t-values for specific alphas, right? So if you're going to do the p-value and you get a t that's in between two things, then you just say that it would be in between those two things for the p-value. I mean, you can do it with Excel, but I don't expect you to do that on Excel. Because Excel has the t-distribution built into it, and you could always figure it out from there. We talked about it, but I don't expect you to do it on the test. All right, so then section 7.3 was equality of means. Your test statistics here are test statistics, page 365. Oops. Now, oops, I missed one. No, that's right. Okay, page 365. When they have the common variance, if the variances are not common, but as long as the sample size is large, you get a different test statistic. In general, though, when we have the small samples, we have to use the assumption that the variances are equal. So just to remind ourselves, the assumptions are that the means are independent. Oh, the random variables are independent. I'll just write it as means since I already wrote the word down. And your variances are equal. I really mean the random variables are independent, not the means are independent, but. All right. 7.4 was test for variances. Your test statistic here is on page 375. Bless you. We also did hypothesis testing for ratio of variances. I'm not going to worry about that for the test, just is the variance equal to a specific value, so it's chi-squared. For ratios of things, we'll leave it to Excel for your ANOVA tests and so forth like that. All right, so then 7.5 was one factor ANOVA. And this is testing your null hypothesis that you've got a bunch of means that are all the same. So this is when you would use Excel to calculate the one-factor ANOVA, or one-way ANOVA, one-tail ANOVA, all sorts of different names for it. So you've got a bunch of independent random variables, and you assume that they all have a common variance, and then you use your ANOVA, the one-way ANOVA, to calculate an F-test, essentially. So remember, for your ANOVA, those values come out of there. But also remember with these that we had the different pieces. Why it works is because we have the different pieces that were all chi-squared, and how the degrees of freedom all fill in each other. This is a reminder of those things. And then 7.6 is when we had the two-factor ANOVA. That was when we had the row effects were all 0 for your null hypothesis for the rows, and you had a null hypothesis for the columns. You also had interaction. And what you're testing, each of those null hypotheses, you're testing against all possible alternatives. For the first one, there would be at least one row effect. For the second one, there would be at least one column effect. Right? Yes?
What's the difference when you use with replication and with?
The with replication is when you might have interaction. The without is when you don't. So, as far as examples go, one of the examples that was in the book was testing gasoline in certain cars, but there might be interaction depending on which gas works better with which car. Versus if you had, say you were looking at, trying to think of something that was not interaction. Say you've partitioned the country into 6 regions and are looking at, trying to think of something that wouldn't. well, say the yield rate of a particular type of crop. There's probably not a lot of effect that being in the Northwest would have for a yield of, I don't know, tobacco in Virginia, for example. There's not going to be a lot of interaction between those two things, so then you would use without replication.
Are you going to tell us when we need to use with or without? Or are we going to just know?
There will be at least some sort of a clue in the problem,
Right.
whether or not there's going to be interaction. Okay. And honestly, the big overall point with the interaction is you should always be testing for the interaction first if you think that there might be interaction. Because if there's interaction, there's going to be you're going to have a hard time determining how to make the difference between rows and column effects. If there's interaction, you don't know what level of interaction there is. All you know is that there is interaction. You don't know which ones are necessarily interacting with which others. So trying to then say, oh, there is a row effect or there is a column effect doesn't really make any sense, because all of that row and column effect might have been taken into account from that interaction variable. It could be the one interaction variable that you have being non-zero is causing that row and that column to have non-zero row and column effect. So in practice, when you're testing for interaction, if you hit interaction, then you wouldn't even bother doing the other two. You would only bother doing row effect, column effect if there's no interaction. Or if you already suspect that there isn't any interaction anyway. So on the exam, most likely I would be saying test for interaction, or have another problem that's saying, oh, by the way, there's no interaction here, do the other.
So with replication is interaction.
With replication is interaction.
Okay.
Yeah. And honestly, if you run into Excel and you don't see the interaction listed as one of your things, you know you ran the wrong one, and you can go run the other one. So yes, on the stuff with 7.5 and 7.6, and then we did 6.7 and 7.7 essentially together, which was regression. Those problems, those three sections, those are going to be Excel interactive. So what I would anticipate, you can do it this way, just like I told you, you can do your homework. If you want to just do it in Excel and type your conclusions in the cell and just email it to me, I'm assuming you're going to email it to me anyway in the test, just email it. And you don't have to write it down. I can just give you the problems, you don't have to write anything down. I'm okay with that. If you're okay with that, I'm okay with that. I mean, I assume you're going to email me the Excel that. Good Lord. The Excel spreadsheet anyway, So then the regression stuff, so you should be able to give me least squares line. You should be able to give me confidence interval. Oops. For the slope, because that's listed on the Excel, right? You should be able to do a hypothesis test for the slope being non-zero. That again, that t statistic is given to you in the Excel, right? The only thing that's not given to you that you need to be able to calculate in Excel again is to be able to find your maximum likelihood estimator for the variance. You have homework problems over that, yes? Yeah, so if you can do it for the homework, it's going to be very similar on the test.
Is that the thing when you do the residuals on the side?
Yep, that's exactly right. Yeah, so you click off that you want to see the residuals, right? Do the sum of the squares of the residuals and then divide by the total number of data points. I think you're going to find this test a lot more computational than the previous one. So we're going to, you have to do some interpretations too, but being able to do the computations, being able to do, I think the big thing is probably going to be remembering your different test statistics. That's the biggest memorization part of it. Yeah, Ben. It's okay.
I know on some of the homework problems we had to do like confidence intervals and stuff too. Is there anything like that?
For which one?
It was like, I don't know, just hypothesis and stuff.
You'll just be doing the hypothesis test too. The only confidence interval that I'm working, because we did confidence intervals on the last test. The only confidence interval I'm interested in is being able to read the one for the beta for the regression line. What were you gonna ask, Sarah? Sorry.
I don't remember anymore.
Okay.
I'll let you know if it pops in my head.
Sure. So yeah, again, probably the most conceptual thing, besides being able to do the interpretation, the most conceptual thing is doing the type 1, the type 2 errors, making sure you understand how to compute those probabilities.
When we put the interpretation, you just would say reject or accept.
Yep.
Whatever. Just reject.
Yeah. Yeah, reject or do not reject is all I'm looking for.
Okay. So
Yes,
you
Dave.
don't need us to know, like, we don't need to know how for, like, ANOVA tests, like how we got to the F statistic, or no?
No, I just want you to do the interpretation off the ANOVA. I mean, I can't really imagine how I would ask a question that wouldn't just be simply regurgitating what was in your notes.
Yeah.
I mean, I want you to understand where those things came from and why the degrees of freedom are what they are. But in practice, all I would be doing is just making you regurgitate exactly what we talked about in class. So without being able to make you come up with something new that would be, well, something new to you. I shouldn't say something new, but something new to you. It would literally just be going back through your notes and saying, "Oh, this is chi-square, and this is chi-square, and this has this many," and it would be literally just rehashing what you did in class. And I don't think that's a very good testable type of thing. I mean, that's just rote memorization.
So for the 1-factor, 2-factor ANOVA, and then regression, it's basically all just reading it off of it.
Mm-hmm. Yeah, just read it and tell me what the conclusions are.
Okay.
Yeah. Yeah, those should be very straightforward. I mean, the hardest part of that might be making sure you type the numbers in right. I mean, for me, the more interesting part is the theory behind it, but there's not a really good way to test the theory behind it. For your purposes, it's more practical in being able to actually do it and being able to get the interpretation. So as far as testing goes, it's a lot more testable to make sure that you know how to do that. So I don't think it's going to be horribly difficult. Which is probably good for you. I think that the stuff that we're going to hit at the end of the semester is more difficult. Because it's going, like I said, we're going to have to get an idea of how do we handle getting a handle on power, for example. That's a harder concept to understand, a harder concept to get grasped. Now, the good news is that the next chapter that we're going to do is going to be more of, hey, can you do hypothesis tests just on different things? So there will be more playing with Excel. So. One of the things I would like to do, it depends on how much time we have in the semester, is maybe do a little bit of stuff in R as well, because that stuff has actual practical purposes outside in industry.
What about SPSS?
I could do some stuff in SPSS.
But it's basically the same as Excel. Like what would we do?
Yeah, it's the same kind of running stuff. You did SPSS in the regression analysis class, right? Yeah, so you've already had experience with that. So I'd rather give you experience with something that you may not have seen or have done
We
very
did
little
R,
with.
but like maybe twice.
Yeah.
We didn't really get I was into going it. to be only like one thing with it.
Yeah, so if we have time, it'll depend on how long it takes to get through the other stuff.
We could do that and numerical.
I could do R and numerical and just get away from
Just to be done with numerical.
Actually, there is one cool thing that we're going to do in numerical with the Monte Carlo simulation that we might actually do a little bit of stuff in R in. That stuff. Being able to do, say, integration just by doing picking random points is kind of a cool idea, for example. I mean, there's going to be some cool stuff with I think there's some cool stuff with Monte Carlo simulation that we can do in numerical. I don't know. I just like the technology to work on a particular day for everybody in the room. That would be fantastic.
I think we deserve a pizza day anyway.
I think it's probably a pretty good bet that you're going to get a pizza day.
Just for all the stress we've had.
Yeah, I think there's a pretty good possibility that you're going to get pizza anyway. Tick marks or no tick marks, I think for putting up with the last 2 days, you should get like 2 pizza days.
Fine, we'll do 2.
Yeah. So anyway, any other questions about test stuff? I don't think it's going to be a surprise. I don't see any reason why it should be. I mean, it really is just a matter of, can you apply the different tests in the different scenarios? That does not mean don't study.
Closing my notebook.
Yeah, I'm done with this. So, if you don't have any other questions, I'll let you have the time to study, finish homework, get coffee, take a nap, eat lunch. Yeah. So we'll get into chapter 8 next time.
And you said it doesn't matter what time we take it Friday.
No, I don't care. We do have a candidate on campus on Friday, but that shouldn't affect anybody. They're not doing research presentations, so it shouldn't affect anybody. So, all right. Enjoy. We should be having pizza in a couple of weeks though, because advisory day is coming. So.